equation of the circle with radius A and center origin r equals to A. Similarly, another example, we convert the Cartesian equation of the circle x square plus y square minus 4x minus 6y minus 12 equals to 0 in the polar form. Now, but x square plus y square equals to r square minus 4 into x equals to r cos theta minus 6 into y equals to r sin theta minus 12 equals to 0. Now, required equation of the circle is r square minus 2r into 2 cos theta plus 3 sin theta minus 12 equals to 0. Now, this is the required equation of the circle in the polar form. Similarly, another example, the equation of the parabola. Similarly, another example, now the Cartesian equation of the parabola is y square equals to 4ax. Now, this converted into polar equation of the parabola. Now, x equals to r cos theta, y equals to r sin theta. Substituting in the equation of the given parabola, now r square sin square theta equals to 4a into r cos theta. Now, both sides are cancelled. Now, r sin square theta equals to 4a cos theta. Now, this is the required equation of the parabola in the polar form. Similarly, another example, we convert the equation of the hyperbola x square minus y square equals to a square in the polar form. Now, at place of x equals to r cos theta, y equals to r sin theta, substituting, we get r square cos square theta minus r square sin square theta equals to a square. Now, r square common, cos square theta minus sin square theta equals to a square. Now, r square into cos square theta minus sin square theta, but that is equals to cos 2 theta. R square cos 2 theta equals to a square. Now, this is the required equation of the hyperbola in the polar form. Now, next we discuss the distance between 2 points in the polar coordinates. If suppose consider first point P r1 comma theta 1 and second point Q r2 comma theta 2. Now, required the distance between these 2 points in the polar coordinates. If suppose consider origin O and OX polar axis. Now, first point P r1 comma theta 1. Now, the point P r1 comma theta 1. Now, the distance between OP equals to r1 and OP inclined an angle theta 1 with polar axis or initial line. Next, to the second point Q r2 comma theta 2. Then OQ equals to r2 and OQ inclined an angle theta 2 with initial line. Now, require the distance between P and Q. Require the distance between P and Q. Now, in triangle OPQ, angle O equals to theta 1 minus theta 2. Now, in triangle OPQ, angle O equals to theta 1 minus theta 2. Theta 1 minus theta 2. Now, from cosine rule, PQ square equals to OP square plus OQ square minus 2OP into OQ cos of angle POQ. Now, PQ square equals to, but OP equals to R1, OP square equals to R1 square plus OQ square equals to R2 square minus 2 into OP equals to R1, OQ equals to R2 cos of angle POQ equals to theta 1 minus theta 2. Therefore, the distance between PQ equals to square root of R1 square plus R2 square minus 2 R1 R2 cos of theta 1 minus theta 2. Now, this is the required distance between P and Q. Distance between P and Q. Now, by using this formula, we can do some examples, numerical examples. Find the distance between the points 5, pi by 2 and 3, pi by 6. Now, in this R1 equals to 5, theta 1 equals to pi by 2, R2 equals to 3, theta 2 equals to pi by 6. Then the distance between the points equals to square root of R1 square plus R2 square minus 2 R1 R2 cos of theta 1 minus theta 2, or that equals to square root of, but R1 equals to 5, 25 plus R2 equals to 3, 3 square 9 minus 2 into 5 into 3 cos of pi by 2 minus pi by 6. Now that equals to square root of 25 plus 9, 34 minus 2 into 5 into 3, 15 into cos pi by 3, that equals to 1 by 2, or that equals to square root of 34 minus 15 equals to root of 19. Now, the distance between given points equals to root 19.